its presentation from China. It's titled China-Egypt Cooperation on Non-CO2 Greenhouse Gases and Sustainable Development in Agri-Food System. This presentation will be presented by Professor Dr. Yinghui Han. She is expert and a professor from the University of Chinese Academy of Science, and she is collaborating with our team in Egypt in the project. So she will present some of throughout quotes of this project, and please you can.
Okay. Thank you. Distinguished Professor Mowat Foda and Professor Mowat, President of National Research Center, distinguished college and guests. Good morning. I'm Yinghui Han from University of Chinese Academy of Sciences. It's a great honor to be here to introduce my university and introduce our cooperation. Recent years, I focus on non-CO2 greenhouse gases and SDG in agriculture food system. Now I will introduce some result. Today I will introduce 4 parts. The first part is about the statement of non-CO2. What is non-CO2? We often heard the greenhouse gases. Non-CO2 is about except the CO2 greenhouse gases. It includes the methane, the nitric oxide, and the fluoride gases, which mainly come from agriculture, industrial, and energy waste disposal, and combustion industrial. We will see this picture. Of course, the CO2 occupied the 75% in the total greenhouse emission, but the non-CO2 only occupied the 25%. Even it's only 25, but its global potential, global warming potential, we name it GWP value, is very higher. For example, methane, it's about 25 times than that of CO2. And N2O is about 269 times to that of CO2. And for fluoride, for example, SF6 is even more higher. How higher? 20,000 times than CO2. It's very higher. Even its emission, the account is very lower, but because the GWP value is very higher, so it's very sensitive. We need to make it very important to research. Now we can see there are six the figures. We will see in all the world, the top 5 country is China. For the non-CO2 emission. The first one is China. The second is US. The third is Russia. The fourth is India. The 5 actually is not Egypt. Egypt is very lower. The 5 is Brazil. I put the Egypt, just want to combine. You will see for China, our non-CO2 emission is about 25 times than Egypt. Egypt, the total non-CO2 emission is very lower, but later I will introduce where in Egypt the non-CO2, the emission is hot pot. And we will see for China, our non-CO2, I forgot figure out the color, what is meaning. You will see the green color for China. The green color, it means emission from agriculture. Yes, in China, the non-CO2 mainly from the agriculture, because we eat rice, a lot of rice growing will emission the non-CO2. For example, the methane, the N2O. And the second is our energy. We have a lot of the coal mine, we build it. So the energy will emission the methane. and the blue one is about the industrial emission, and the last one is waste plant, is waste industrial, and you will see we are similar. For China, is similar like the U.S. the emission, and very different with Russia and different with India. Its non-CO2 emission mainly from the agriculture. For China, we occupy the main part agriculture, but not less than India. India, the non-CO2 mainly from the agriculture. For Egypt, is different. Egypt, the agriculture occupy the non-CO2, and the energy, Egypt plant the oil, gas. So the energy also emissions some methane, and of course for Egypt the waste industrial will disposal will emission some the methane, the N2O. This is the Egypt emission. Now we can see all the world the special thermovariate global emission about the methane and the N2O from 1970 to 2023. It's a long history. It's a long time. You will see for the methane and N2O, they're from the special time value, some is similar, some is different. For all the world, we can see the methane grow up, is stable grow up for methane. But for the N2O, just from 2000, it can increase. So it's a little different. But of course, for Africa, the net CO2 is less than the other countries. You will see in China and the east of China and some part of India, some part of the Europe, some part, yes, Europe, you know, has the oil, gas, and for China, the agriculture, the coal mine, they will emission the non-CO2. And for some Brazil, they also Amazon forest, they are natural emission, so they also have some non-CO2 emissions. For the American, the North American, they also have some emission about the methane. For N2O, is similar part emission, but you will see a little different. For example, for China, the N2O mainly from the industrial. And we also use the nitrogen fertilizer, so we has the N2O emission. For the other countries, for example, the other countries from the 1970 to 2000, they have the very growing the car industrial. The car industrial, their emission the N2O. But after 2000, they control the tail gases, and they put some catalyst to control the tail gases, so their N2O is less, is decreased, so it's a little different. Now we can see some China and Egypt, the emission is a little different. For China, the methane emission mainly in the central and the east of China. You know, in China, the east of China, they developing very fast. I mean, we need to use more the coal mine, coal. We use more the natural gas. So the energy will emission the methane. And for the agriculture, we are mainly built in northeast of China. So northeast of China also has some methane emissions. From the tempo trend, we will see from the 1970 to 2023, we have also the growth increase. But after 2010, the speed is lower, is decreased, because we publish the new policy. We control the coal mine. When we produce coal mine, if the methane emission, we will collect them. If more than 10%, we must, for example, some company, they do the coal mine. If the 10% natural gases from the coal mine, they must be collected. And then must be utilization. It need recycle and can make these gases to be the electric power or the other energies. But lower, if then lower than 10% for nowadays, it haven't the limitation. But later, because our technology is grow later, so maybe the limitation will more strategies for China. And Xinjiang has a lot of the coal mine. The Shanxi province also has a lot of coal mine. So you will see in the central part, the red one, it means this part we have heavy methane emissions. But after 2020 years, we published the carbon neutral GALE. So nowadays, the limitation is very, very tough. So for the company, they must be controlled the methane. And for Egypt, actually, even you see the color, the red color is more dark than China, but actually the emission is lower than China, very lower than China. I just want to give you an example. For Egypt, we can see the hot spot mainly in the Nile River, close this part. And this part, some from the natural, some from the human beings. So you will see in Egypt, you have the oil gas, produce the oil gas. Of course, we have some waste deposit, and we also has the natural, from the natural source. So I want to notice that in those days, sometimes we need to trade with Europe. Maybe later they will calculating our trade, carbon trade. So for us, Egypt or China, we must be process accounting the methane. Some natural part, actually, we need to delete it, because only human being can conclude the carbon trade. I mean, if later the carbon tax is higher, we will see from the Nile or from our oil gas is some methane emission. But for the natural, actually, we do not need to pay this part. So we need to cooperation with the accounting of methane. Let's see the N2O emission. The N2O emission in China, just now I mentioned, mainly from the industrial and some part from the fertilizer, because in the old days China used the nitrogen and ammonium fertilizer. But those days, especially after 20 years, so we control use the nitrogen, the ammonium fertilizers. We use the other fertilizers. So this year's, especially for these 5 years, it's controlled very good. But you will see from the 1970 to 2020s, the N2O is increase very fast. So now we need to control. And for the Egypt, is also in the Nile River, this part, we will see some N2O emission. Of course, the same, even the color, the red color is maybe more heavy than China, but actually the emission is lower, is very lower than China. But I just want to say for Egypt, the N2O emission some from the N2O, some from the natural source, some from in the new we have shipping. The shipping has some N2O emissions. But even it's from human being, we also need how to calculate the N2O. N2O is carbon. Later we will pay the carbon tax. But even it's emission from the ship. But actually, for Chinese scientists, we just do this research. Who pay? For example, for China, we produce the jeans, the clothes, but we haven't wear it. Actually, the Europe, they wear it. We trade with them. They wear it. They use it. Who pay the carbon taxing? It's a very complicated question, and nowadays, for Europe and American, they said, who produce these goods, these clothes or these jeans, they need to pay the carbon tax. But actually, it's not true. We haven't used it, we just produce it. That's why we discuss SDG. We need sustainability develop skills. This sustainability develop skills is develop rights. I mean, who use it? Who can pay the carbon trade? So every year I attend the COP. We will discuss. We're fighting for that. But of course, it needs balance. Actually, it needs balance. But which part is the balance point? I mean, maybe each part need pay. We produce it, we pay a little bit, or pay part of it. For who use it? I mean, for the developing country, for the developed country, they use it. They use these goods, so they also need to pay. Both of us need to pay, but where is the balance we need to discuss? I think maybe this is very important. Just now I mentioned for NEO, we shipping to the other countries. Even the shipping company belong to Egypt. But the taxi, the carbon taxi, actually is not only paid by Egypt. It's both need to pay it. We need to find the balance point. Okay, let's discuss another issues. It's about monitoring and accounting. Just now I mentioned we need precise accounting, but the first we need to monitoring. Monitoring needs from the three side. We need to use the satellite, we need to use the UAV, we need to use the ground, because we need to combine these data. And we do need very precise data, but use the different tools. Actually, the data is very different. So we need to combine them. We need to make the same unit. It's very difficult. It's a very difficult questions. The scientists now they do that. And from now, IPCC, they always use the bottom-up approach. They give the different country the emission factors, but that factors is too big range. And for China, some part, for example, in my research for the coal mine, with my comrade, we calculate in China's coal mine the methane emission factors. It's very difficult. Is very different with the IPCC. The factors is just half the IPCC factors. It means later, if we want to show this coal, we need to pay. If we use the IPCC factors, we need to pay more. But actually, in our method, we only has half the factors. And nowadays, cooperation Professor Yashad, we also has a little part about the agriculture in Egypt and China, these factors, the agriculture non-CO2 emission factors. We need to process the details, the factors. Later we will change the data. We will publish, maybe we will change the IPCC. And another way is the top-to-down approach. It's difficult to say which method is good or not, but we need to combine them. And IPCC, their satisfied method. From the top-to-down approach, we use the satellite remote sensing and then combine the ground data. And nowadays, we think this way maybe more has equal rates for all the countries. Not only depends the satellites, depends the different countries, scientists, their ideas. We think maybe this is more good for our developing countries. And for now, there are some satellite remote sensing can monitoring the non-CO2 greenhouse gases, but actually is less, is not too much. And some quilt, some need to plant, and only this part. And for China, especially for our cars, we will to set up the new satellite. Later I will introduce about it. Okay, we will see for the non-CO2, especially for the agriculture south, because it's all these non-CO2 gases is not from the point source. It's a very big source. So it's escaped point. So the accounting is very difficult for the scientists. It's a very big challenge for us. And for now, we always use the three score. The national score, the regional score, and the point score. The point score mainly suitable for some plant, for example, the power plant or the steel plant, something like that. But for the agriculture, the plant, the area is big, is huge, so it's suitable for the region score. Now I will give you an example. For China, mainly the rice built in northeast of China. We have 3 provinces there. We plant the rice. Chinese always like the rice. And for now, because the Chinese rice, actually, in my research, we found the IPCC emission factor also larger than our research. Why this? Because IPCC, they are general. We cannot say they are wrong. They are not wrong. They are just a general model. They are general model for some Asian countries, for Thailand, for Japan, of course, for China. They are just general. But actually, the different country, they have the special characters. They have the different the performance. For example, for China, our rice is different with Japan rice. Our rice built in the cold area, a very cold area, is different with the Japan the area. Japan more warmer, Thailand more warmer. So for us, actually, methane emission actually is lower than the warmer place to emission the methane. So it's very different. And in my group, our research used the top-down observation constraint and bottom-up to combine these data. And this part is just now I mentioned in China, we plant the rice. We name here is Sanjiang plant. It's a huge rice plant. Okay, all this part is the different years. And we will see the different season variation in methane emission is very different. So we will use the different growing ways will affect the methane emissions. For China, with our every year, we only plant one time for the source area. Of course, in China, we also has Zhejiang or the other part, the source part, but they are less. They produce the rest is less. And this part, every year, they produce the rest twice. It's similar like Japan or Thailand. So that part, actually, their emission, their methane is a little higher than the source part. Okay. 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 I will quickly to describe. Okay, let's skip this part, the detail about some science. Okay, I mean for the different plant, the flooding and drying will affect the rice methane emissions. So for the different ways, we can control the rice emissions. And this part, it means for the different plant, the methane emission is different. It's similar actually for Egypt. Actually, for the different place, their emission, non-CO2 emission is different. So we need to research the details and use the IPCC factors. Actually, it's too general. It's not special. We need our own countries the emission factors. For mitigation, I will quickly to discuss about it. For greenhouse gases, actually we have these ways. We monitoring first and then got the data. We accounting them. We got the emission factors, and then we will find the ways how to mitigation or control the non-CO2 greenhouse gases. Of course, include the CO2. And for us, we use the different ways to control the methane from the agri-food systems. We use the water, carbon, nitrogen, three ways to control the methane from the rice. Of course, our test plant, we do the pilot score in northeast of China, and Professor Yasha and me, we do a same project in this part. And later, I think we can do the similar research in Egypt. We will find a good place to test our result, and we use the different ways to control the methane in Northeast agriculture high-tech zone. And we produce and develop R&D some battery, and we develop and research some materials can control the soil emission, the methane. And nowadays we found it useful. And all this is the figures about our materials, the different dose of macro bait agent will vary effect. And now this is the last part about that. Mitigation, the non-CO2 greenhouse gases, and then what we do, we need to use this, actually some part we cannot control, we cannot decrease them. How to handle this part? This part for agriculture, we cannot decrease. We can collect them, and then we can, for example, for the methane, we can become methane to hydrogen energy. That's Professor Yasha, very good at this part. So we cooperation. We connect the non-CO2 greenhouse gases then to the new energy. This is our doing. And it means we not only control them. Of course, if we control the non-CO2 greenhouse gases, you need to pay more money, you need put more money on it. but actually we make it the new energy, so we can benefit from the technologies. And we also do some connection with the society research. We use the DID or OMI, these ways to research about how, if we control the non-CO2 greenhouse gases, and whether it affects the well-being, whether it affects the SDG, something like that. And this part is we do some non-CO2 emission, how affect the climate impact, and how the SDG indicator can change or not, and well-being, whether their salary is effect or not. For example, for China, in Shanxi province, most normal people, they worked in the coal mine plant. But if we control the methane emission, it means they need put more money on their plant. The workers, their salary, whether they are low decrease or not. Later we found actually if we control these non-CO2 greenhouse gases, we can balance them and then make all the society can development, and also we got the environmental benefit. And so the next, I think why we are here, we just want to cooperation China with Egypt, especially for CAS and NRC. I think we are the top the science institute of both our country. We can R&D the new technology to control the non-CO2 greenhouses. Not only about that, we do the climate action, and we can make both our country to handle the tax, the carbon tax, the carbon trading about that. And I do appreciate, I work with the National Research Center, Professor Yasha and me. Nowadays, we have a co-funding research project. It's about the innovation in climate-resistant agricultural food security based on satellite intervention, inverse accounting and mitigation strategies of air pollution and greenhouse gases emission. I hope we can, from this start, this is just the beginning. Later, I think we can more cooperation with all the gases and all the comrades. So welcome to China, welcome to University of UCAS. Thank you very much.